Hello, I'm going to show you how to demonstrate memory corruption detection using Memory Validator. First of all, we need to enable the memory corruption settings, so click on the cogs icon in the toolbar, get the settings dialog up, click on instrumentation, choose memory corruption, click the memory corruption settings, ensure that's set to 1. This is going to make it very slow, by the way. And you can set these how you want. I'm going to leave those as they are. Click OK, click OK again, say yes, you understand it's going to be really slow. Okay, click on the rocket icon, click on the rocket icon, click on launch and native net applications. I'm going to launch this native example, which is one of the examples that ships with Memory Validator. Click the launch button and wait. It's going to take a while for this to start because it's going to instrument the program, and then once it's instrumented the program, every memory allocation is going to be checked to make sure there is no corruption. So things are going to be a bit slower than normal. So just twiddle your thumbs whilst this happens. And we can see the program is running. We can see activity on the summary display, and the program has appeared. Click memory errors, choose memory corruption, allocate memory and overwrite end of memory. This is where it's a bit slow because the example actually parses some source code and then displays your fragment of the source code, and that's a bit time consuming, all these errors, all this error checking taking place. So we'll just have to watch this slowly progressing. And I don't want to see that again, so and then hit close. So that's the code it's going to execute. And this is how many times it's going to do whatever you want it to do. So I'm just going to let it do this, which is one allocation once for 10 bytes with no reallocations at all. So do that. And you can see Memory Validator has detected an error. So if we click on the error, and you can see in the Analysis tab, it's saying I haven't found any corruptions here, but by the time I got to here, I had. So this line here is where it's okay, and then sometime afterwards it detects it's not okay. So you can look at that line and think, what's that? Is that suspicious? Well, it is, because that's actually an overwrite at the end of the array. An alternative way of looking at this is if you go to the Memory tab, you can see the errors have also magically appeared here on their own. And you've got this, pretty much you've got the same information here. So it's detected the error in the constructor of the test memory dialog, and it didn't have the error at this line here. So if we expand that a bit, you can see the test memory dialogs there. So if it's okay here on this line 1634, it's okay here, and then it's not okay when this thing's destroyed, which happens at this line here, you can infer that this is probably your culprit line, which it is indeed the actual line that causes the memory corruption. So there you go, that's how you detect memory corruptions with Memory Validator. It's pretty straightforward, only works for debug applications, and it won't actually tell you the location of the corruption. It tells you the first location of a function call that happened immediately after the corruption. That's just the way it works. So that's memory corruption for you with Memory Validator. Thank you.